Hi, my name's Hayden. This is day 13 of doing Leetcode until I get a full-time job. This is Leetcode 416, the partial equals subset sum problem, and this is day 13. The problem goes as so. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both subsets are equal to each other, otherwise return false. So what this problem is asking is, can we create any two combinations of subsets, or we can partition it so every element has to be included in each subset, such that the subset subarrays or subsets have equal sums. So in this case, we can easily see that the answer to this problem is going to be subset 7, 2 along with the subset 1, 3, 5. And these equal each other with 9, so we return true. All right. We're gonna have to, in order to solve, we're gonna have to reframe this problem. And the first thing that you should notice is this part right here, 9 equals 9. If we have this array and we split it into two parts, these two parts are gonna add up to the total sum of the array. So if we have the sum of the array equals 18, the two values that the subsets are gonna sum to is gonna be half of this, so 9. And along with this first observation, so the first observation is this: the target of the, and then I'll say this before I write this down. After we get the sum and then thus the target, so the value that each subarray must have in order to be equal to another, we kind of reframe this problem into can I create a subset such that the sum of that subset equals the target value. So I'll get back to this. The sum of the subsets must be equal to the sum of the array divided by 2. And then another observation we can make is that if the sum of the array is odd, there can't exist two subsets of equal value. This should be pretty intuitive. So if we have, say, 19 as our value, we can never create, with integers, we can never create two equal values that add up to it. So that's our second. And then our last kind of observation is going to be the biggest leap. We're going to want to, as I said earlier, we're going to want to work on the problem of creating a subset that equals our target value. So if target equals sum divided by 2, then our new goal is to determine if a subset exists that sums to target. So this is our new problem. Our new problem is number 3. Can we create, or does a subset exist such that it equals target? How are we going to kind of do this? Well, we're going to do this with a set. And we're also going to have our target down here. Target equals 9. And we're going to have a set. Right now, this set's going to start empty, and we're going to be iterating. We're going to be iterating through this array, starting at 1. And let me just move you down a little bit. All right, so starting at 1, this set is going to contain all elements or all possible subset sums left of the current index. So all possible subset sums left of the current index at index 0 is kind of nothing, so we'll ignore that for now. And then we're going to want to add 1 to all those previous, or add the current number to all previous subset values, and then add the current number itself afterwards. So right now this would be, we add 1 nothing, okay, and then we give 1 to the set. All right, cool. Now we're looking at 2. We're going to add, now we're at 2. We're going to add 2 to all previous elements. So that's going to be 1. So we're going to do 2 plus 1 equals 3. And then we're going to add to itself, 2. Now, as we can see, up to this point, all possible subset values our set argues is 1, 3, and 2. And this is clear. So we have the 1 array, the 2 array, and the 1, 2 array. And that's 1, 2, and 3 respectively. And this pattern is going to continue as we go along. So now we're at 3. And we're going to first add 1 to 3, or 3 to 1. So that's 4. We're going to add 3 to 3. That's going to be 6. And we're going to add 3 to 2, which is 5. Now we contain all possible subset sums left of this value. Then we have 5. We're going to add 5 to 1, 6. 6 is already in there, so we'll kind of ignore it for now. We're going to add 5 to 3. This is 8. We're going to add 5 to 2. This is 7. We're going to add 5 to 4, 9. Oh, we've just found our target. So we're going to end execution here and then return true. If we continue this and we go through all the numbers in our nums array, if we don't see target in our set, then we return false. And another thing that I will point out is that we'll never add to the set a sum that's greater than target. So the sum is going to be kind of bounded by target of t. And I'm going to go quickly over to some code to explain it to you. So first we're going to find the total and the target. And I guess we should move it more like this. So we're going to get the total, just sum of nums, and then if the total is odd, return false. Otherwise, get the target. And then we're going to create our sums array. If the nums is greater than the target, this is just another observation. So if the num, we should probably do this here also, if total equals 2, or max of nums. Let's move it here. If max nums equals or is greater than target, return false. All right, and we can actually then get rid of this. And then we're saying this because excuse me, we say this because if there's a number greater than the target value, because we have to use that value, say 10 in our example where 9's our target, because we don't have negative values, this is 1 to 100. Because we don't have negative values, this can never get down to the target. So that's why we can make this, if the max of nums is greater than target, return false. And then we're going to go in, and then if num equals target, obviously return true. And then we're going to get the current sums. And then for the cur sum and cur sums, we're going to have a new sum. If the new sum is less than or equal to target, we're going to add it. So this is our little bound of O of t on our size of the array. And then we'll add the new sum if it is less than or equal to target. And then we're going to add the num itself. And if target is in sums, return true. So this is just a check. If we found our target, return true. And then if we exhaust all possible number and subset combinations, return false. And we can submit this and see that it works, and then we'll go over the runtime real quick. All right. So with our runtime is going to be kind of ugly. So for the space or time space complexity is easy. For space, it's O of t. All right, what's our time complexity? Well, our time complexity is going to be worst case. It's going to be O of n times n times max. Why do I say that? Well, we know that our worst case scenario is we're gonna have to loop over everything in this array. So that's where O of n comes from. This n's unavoidable. So that's fine. Why do I say that this operation with the set manipulation is n times max? Well, that's because for each iteration we can potentially find the sums of the max element in the array n times. So basically, our worst case scenario is if every element in the array equals 100, say. Our worst case scenario is, or if every element equals 1, our worst case scenario is kind of, it's strange, but it's true. I can't. Basically, we have this latent space of which values can equal. And this space is n times max. Or if it's easier to think about, this is the sum. This is the sum of array. And while this sum is easy to think about as this, the worst case scenario is the max times n. That's why I kind of said that, but we could iterate over all possible subsums in our array, and that's where this part comes from. But I think rewriting it as n times sum is easier to digest. But as we know, max, the max here is actually 100, so we could kind of ignore it and just say that our runtime is O of n squared. But beggars can't be choosers. That's more precise, but this is a more generic bound on it. And then likewise with t, the t element is obviously sum divided by 2. So we can make this this is bounded by O of sum, and then sum is O of n. So it's kind of weird to think about with this problem. It depends on how you want to define it. If I were to define it, this would be how I do it. Time equals n times sum, and space equals O of sum divided by 2, or just sum. So this was, I think, day 13. So almost coming up on 2 weeks of doing this. This was Leetcode 416, partition of equal subset sum. And it had a time complexity of n times the sum of the array and a space complexity of O sum of the array. Yep.